Welcome to our webinar. My name is Larry Pearson, Vice President of Marketing Alliances at Impetus Technologies, and I will be your host and MC for today's session entitled Build Spark-Based ETL Workflows on Cloud in Minutes. Just a short introduction to Impetus for those who may not be familiar with us. We've been working heavily in the full spectrum of big data analytics for the last 12 years. We're actually a 20-year-old company based in the heart of Silicon Valley that today specializes in working with large Fortune 500 enterprises, helping them to achieve the elusive goal of a single source of truth. And as a result, you see our mission statement here on this screen, enabling a unified, clear, and present view of your business. We're going to start again with another way to add some interactivity to the webinar by asking you to respond to a poll. And the first poll question says, what are the challenges you encounter with your ETL processes on cloud? Choose all that may apply, and you'll see 5 different options there. Data movement bidirectionally to and from the cloud, lack of cloud-native integration, manual development or lack of tools, lack of having the right experience levels or skills, and lastly, data standardization, and choose all that may apply. We're going to leave that poll open for about 15 minutes, and after that, we will share the results of the poll with you, and as I said, it's always an interesting way to add some interactivity to our topic today. Let me now introduce our speakers today. The first is Puneet Shah. Puneet is known as Mr. StreamAnalytix inside Impetus, and as a result wears multiple hats. He is the Director of Engineering for our team here in the U.S. and is also the Senior Solutions Architect. Puneet's been a key member of the core team developing solutions for ETL, Apache Spark development, and streaming data analytics, and works directly with our product management and engineering teams to define, deliver, and support the product roadmap. He also works directly with some of our largest customers on technical strategy, architecture, and implementation issues. Also with him today is Saurabh Dutta. Saurabh is product manager for StreamAnalytix, and in that role he leads multiple engineering and R&D teams. Along with Puneet, he was also one of the early team members who designed and developed StreamAnalytix. Saurabh brings a strong blend of both business and technical knowledge and is responsible for translating complex requirements into the product capabilities that help address our customer objectives. His special areas of expertise include big data analytics, advanced analytics, and cloud computing. So at this point, I'd like to hand things over to Puneet Shah to begin the content here in our webinar. Puneet, over to you.
Thank you, Larry. Hello and a very good morning to all of you. In today's webinar, we shall talk about ETL on cloud, how enterprises such as yourself are either considering or already leveraging ETL workloads on cloud. If you are considering adopting cloud for ETL, we shall be discussing the benefits and must-haves that shall help you in your decision-making process. While if you are already using cloud for your ETL workloads, what are the potential challenges that you could be facing, how you could overcome those? These are also some of the other aspects that we'll cover in this webinar. We shall introduce and demonstrate a use case on StreamAnalytix, a self-service data flow and analytics platform that helps you build and manage your Spark-based ETL workloads on cloud. A survey conducted by the International Data Group last year revealed that at least 73% of the enterprises are now running a portion of their production workloads on cloud. The average cloud budget has doubled in the last 2 years. The IT partners in these enterprises are now feeling the pressure to migrate more and more of their workloads onto the cloud. It's predicted that by 2020, about 90% of the enterprises will have some or all of their workloads running on the cloud. While the rate of adoption for cloud is increasing than ever before, enterprises are also building strategies and architecture to support a hybrid model of deployment. That's having the agility and flexibility to run the workloads in cloud and also on their on-prem data centers. the primary driving factor for this is because the data is residing on both sides. You have data warehouses that are traditionally been on the on-prem data centers for a while, and now more and more applications and modern architectural decisions are letting people create these data centers or data lakes on the cloud as well. As a strategy, enterprises are also preferring to run their workloads not just with one cloud provider, but with several of them. In fact, the retail industry has been the fastest adopter of hybrid cloud strategy, with more than 90% of the retail industry believing that hybrid is the ideal mode of deployment. It gives you a lot of flexibility and also gets you more workload and computation across different kinds of tools and services that these cloud providers offer. Now, most of you are already familiar with this term. ETL workloads have been around for 3 decades or more. As enterprise systems grew, ETL workloads kept fueling mission-critical business applications and opportunities by extracting information from multiple sources, constructing meaningful insights, and trying to create a unified view of all your data lakes and data warehouses to give a centralized reporting system. This, of course, begs the question, then why move to cloud? Now, as businesses grew, the ETL workloads also continued to grow and became increasingly complex. There are several challenges in continuing to run these ETL processes in an ongoing manner on on-prem data centers. Ongoing database tuning and performance tops that list. Higher and higher investments in supporting and increasing the database and your data lake footprints. Maintaining and managing the legacy ETL code and trying to fine-tune it to the last possible extent to make sure that they can keep up with the ever-increasing data growth. Cloud, on the other hand, has become the gateway to digital transformation. With the proliferation of device connectivity, multiple customer touchpoints, improvements in processes that can collect and store information, ever-increasing data growth, this has all helped in generating new business opportunities and create insights to have a customer delight experience. But at the same time, it also puts an enormous amount of pressure on the IT to create capabilities that can respond much faster to business needs. They are able to support streaming and batch requirements, are able to generate actionable insights within seconds when an event occurs, scale out and scale up and have faster access to infrastructure on demand, significantly reduce their total cost of ownership, and of course, leverage the existing skill set that you already have in order to support and create these new modern applications on cloud. Now, cloud provides massive capacity for scaling. Imagine your current on-prem ETL workloads that take hours to run. They can now be completed in significantly less time by executing them on the cloud by simply horizontally scaling out the hardware. Compute resources which aren't so easily available on your on-prem data centers because you need to go through a long cycle of approvals and clearance and getting the infrastructure, setting it up, making it available. This all simply goes away on the cloud where the infrastructure is available in an on-demand basis. It's very common to see a pattern in most enterprises where the ETL jobs are usually scheduled on a nightly basis, primarily to avoid the constraints of available capacity during the peak hours and also not wanting to put additional load on the existing OLTP systems. But the elastic nature of cloud lets us change this entire paradigm of how ETL jobs should operate. It's pushing the boundary of the traditional batch ETL jobs, which are taking hours and hours to execute. They are now transitioning more and more towards a streaming nature. So there's a complete paradigm shift where the significant value that the business can gain by simply reducing significantly the ETL workload time duration to get insights has grown up, has shot up with cloud. Now, as more and more modern applications are also being built, enterprises are choosing cloud-native data warehouses and data lakes. This also supports the whole argument of running ETL jobs on cloud so that you can ensure the close proximity or the nearness to data paradigm, which also benefits from a computation and cost perspective. Another major advantage of running ETL jobs is having different kinds of hardware for different jobs. Choose the hardware best suited for the job that you are planning to run. For example, in one of our customer cases, we were required to invoke a machine learning-based scoring model as part of the ETL chain. Now, given the high throughput, because this was an IoT customer, the volume of data that was coming in was very high. So given that high throughput of the incoming data and, of course, the complex nature of the model and the computation needs it had, we chose to go ahead and run that particular ETL job on a GPU-based cluster. Cloud infrastructure allowed us to do this, where we could schedule a particular ETL job and point it to a small nodes of a cluster that's running off GPUs. Whereas traditionally, had the same job been on an on-prem data center, of course, this wouldn't have been possible because literally, usually on the on-prem data centers, what we deal with is an homogeneous set of clusters where almost every node looks alike. From a total cost of ownership perspective, cloud also lets you pay only for what you use. For instance, most of the times, the ETL jobs are scheduled. They take a couple of hours to run, and once they are done, the cluster on the on-prem is sitting idle. But on cloud, you can really run transient clusters. So when the job kicks in, the cluster gets created, the job executes on it, and once the job is completed, the cluster gets terminated. Similarly, if you're using or running streaming jobs, during your peak hours when the volume of data is pretty high, you can have the cluster grow. And during the off-peak hours when the volume is significantly less, you can shrink the cluster. This way, you really are reducing your total cost of ownership by paying for what you use and not for just simply running and maintaining that infrastructure on-prem. However, the question is, are these capabilities enough to build or migrate ETL jobs on cloud? Imagine for a moment if you are required to run and manage all your ETL workloads on cloud. What this would take in order to make it happen. Traditionally, you are used to using a tool on your on-prem data centers, which is graphical, visual, lets you build your ETL jobs in a much simpler way where the resource skill set needed is much like running Java code programs or Python or something of that sort. But the moment you want to migrate to cloud, the skill set required is very different. Would you not prefer to have a strategy that can help you build and manage your jobs in the same graphical equivalent experience? StreamAnalytix, an Impetus product, an enterprise-grade, robust ETL platform combines all these must-have qualities of a cloud, but at the same time, it brings in a graphical visualization that helps you build and manage your ETL workloads on Spark for cloud. It's a self-service data flow and analytics platform. Again, the emphasis on the word self-service. So no matter who you are, a developer, a business analyst, or a data scientist, you can use StreamAnalytix to build your ETL workloads, your data prep activities on the cloud in a graphical drag-drop manner. It lets you build your ETL jobs in streaming or batch paradigm, all the way from developing, debugging, deploy, and monitor in an intuitive graphical interface. StreamAnalytix is a powerful platform for ETL on cloud. It's enterprise ready. It provides a full-fledged monitoring capability for your ETL jobs. The platform also supports a migration path to move your existing on-prem ETL jobs to the cloud and yet have the same visual experience. And more importantly, it's fully compatible with all the cloud providers, whether you are choosing to use AWS, Databricks, Azure, or Google Cloud. StreamAnalytix lets you build your workloads and target one or more of these cloud providers to execute your ETL workloads. With this, let me invite Saurabh to give us a demonstration of StreamAnalytix.
Thank you, Puneet, for that overview. In the demo today, we are going to show you a reference ETL pipeline from the telecom domain. The objective of this use case is to show how you can process data on cloud from multiple sources and upsell by recommending relevant plans to customers based on their usage patterns. So here we'll be reading data from call data records, commonly referred as CDR, collected over a period of time from S3. We'll enrich this data with cell tower information kept on Redshift. Once we have data from these two sources, we'll apply certain preliminary checks to ensure data quality, and then further enrich the data with customer billing information, which is an on-premise database. We'll then calculate some important metrics. We'll use data science to identify usage patterns and associated clusters. For this, we'll leverage Amazon SageMaker. And finally, the process data will be persisted back in Redshift. Now let's see step by step how you can get your use cases implemented on cloud. Typically, you will start by writing the entire program yourself, and this will actually need you to write hundreds of lines of code. You'll then have to bundle the entire jar and upload it over S3. And in order to run this on cloud, you'll have to upload it over S3. The next step is to set up a new cluster. You can either use or launch a new cluster from this terminal, or you can use an existing cluster that is already spawned out. We need to perform certain actions like configuring the Spark command on the Steps tab. But every time you make any changes, you'll have to update the entire program and do all over this again. This is just one way of submitting a job to the cluster where we are utilizing the interface provided by AWS. There could be other ways as well, like using the command line interface or using AWS SDK to create your own orchestration code. But these two will have their similar challenges. I'm going to show you how all of this can be achieved over a visual interface, and then you can compare and feel the contrast between doing all of this yourself versus doing it over a graphical tool like StreamAnalytix. But before we do that, let's look at the typical challenges with the manual approach. Skilled resources. You really need to have skilled resources to create and manage your ETL workflows and managing them on the cloud as well. There is a big talent gap in the market, and this might become a showstopper for you. Time to market. Since we are hand coding everything here, you are also looking at months to years before you can actually ship your product into the market. Another thing that I want to highlight is clusters. Clusters are the most cost-intensive resource on the cloud, and hence the emphasis is always on utilizing them effectively. Every second your cluster is idle without any workload, you are incurring unnecessary dollars. On vanilla cloud, there is nothing to help you with saving the cost directly. So often to achieve an end-to-end goal or a business use case, you may require to configure more than one job. And then these interdependent jobs or pipelines should also be stitched together logically to achieve the end goal. You'll either have to write additional code or third-party programs to achieve the orchestration between these various jobs. And lastly, imagine you have thousands of such jobs running, and all the challenges above will be multiplied and become even more complex. Managing these jobs will be a nightmare. So you really need a single interface where you can manage and monitor all your jobs, clusters, and workflows. Now let's take the same example and see how we can achieve this by using or implementing this over a visual interface. In the demo today, I'm going to show you visually connecting to multiple sources, how you can ensure data quality management, how you can prepare your data by making some external calls or joining with various sources, deploy machine learning for identifying patterns, apply standardization and unification on the data, which is an important aspect when you are creating a single source of truth. Finally, visually storing the data into a cloud-based data store. We'll start from the pipeline canvas. Here, you can drag and drop various operators and create your ETL jobs on the cloud. This interface allows you to create both streaming and batch jobs for your use cases. On the right-hand side of the canvas, we have 4 sections. Channels correspond to the data sources where you could read data from. Processor section has all the different types of transformations that you can apply on the incoming data. The analytics section comprises of various data science and machine learning operators. And finally, all the various stores that you can write data into are available under emitters. We have something called as auto inspection. So this lets you get inside whatever happens inside of a particular processor or a channel. In just a couple of minutes, it will quickly read through the data, and you will get to know what's happening inside of a processor. So as you'll see slowly, one by one, each of the operators present over here will automatically be inspected one by one, and whatever data is present on whatever data is processed on that particular operator will be shown below. We started reading from the CDR data. Eventually, we also connected cell tower information, and then there is a join that you can see. Often in a typical ETL process, we need to join multiple sources, and in StreamAnalytix, we have provided a join operator specifically for this use case. So you can see how easily we got the pipeline started, and just by dragging and dropping various components on the canvas, we are able to see how the data is getting transformed in the data panel below. For some of the common ETL challenges like data quality management, we have created visual operators. You can define your quality rules and decide what's happening in the data if the data does not comply to these rules. In this particular example, we are seeing that if the target numbers are null, we are discarding all these values. There are some operators that also change the structure of the data. For example, when we do aggregation, you could see that we had 12 columns that were getting inside on this particular operator, and as soon as we applied aggregation, the number of columns just remained to 3. Although we are working on the cloud with cloud operators, you may need to connect to sources that are external to cloud, or in some cases, you also need to connect to your in-premise stores. These cases can be very easily handled in StreamAnalytix. In this example, we are reading PII information from customer profile database that resides in your premise, and we can also fetch and join this kind of data in StreamAnalytix. You can keep adding operators one by one and create your cloud-based ETL flows. In fact, you must have seen this in a lot of traditional ETL solutions as well. While building this tool, we realized that a lot of our users want to directly work on the data instead of dragging and dropping components on the canvas. So we wanted to take the interaction to the next level, and we came up with the functionality that lets you work on the data directly. All you have to do is now focus on your business outcome. For example, we have 3 types of values for streaming TV: no, no internet service, and yes. If we have to exclude a value from here, say no internet service, all we have to do is just right-click on exclude. You'll notice that on the canvas, the operator is automatically added. Also, the rule is applied for excluding all the records which had streaming service as no internet service, and the panel also shows the updated records. Another aspect that was missing was the ability to integrate data science in your ETL workflows. Machine learning can have a huge impact on the quality of the data, and it gives you insights that were not possible before. StreamAnalytix now lets you integrate these data science algorithms very easily on your workflows. For instance, in this example, we are leveraging Amazon SageMaker-based algorithm to predict and associate a cluster with the user. In a lot of cases, you build an ETL pipeline, but the configuration or the rules change frequently. You may want to achieve this without tweaking or editing the pipeline. In such cases, you can configure rules externally in the rules file, point to those files in the rules operator, and the outcomes can automatically be adjusted over here. Finally, in this pipeline, we can see how you can just drag and drop and persist all the process data into a Redshift operator. So far, as you want to implement any use case, you can visually achieve this through pipelines on the canvas. In this particular example, we can actually implement end-to-end use case without writing even a single line of code.
Thank you, Saurabh, for showcasing how quickly and easily we can create visually ETL workloads on StreamAnalytix. StreamAnalytix has more than 150 ETL functions which let us build all these ETL workloads for cloud in a graphical, easy-to-use manner. These workloads can then be used to target on any of the cloud providers, may it be AWS, Databricks, Azure, or Google Cloud. And we shall now in the next section also see how StreamAnalytix provides a unified view across all these cloud providers. You create your ETL jobs on the graphical canvas. Once you have created those, how you can deploy and manage clusters across these different cloud providers. Over to you, Saurabh.
Thanks, Puneet. Now that we have implemented a use case, the next task is to deploy it on cloud. In StreamAnalytix, you get a unified view for all your pipelines on this page. Here, all the pipelines that you create for different cloud providers like AWS, Databricks, Azure, or Google are listed. Like you can see a few over here. For example, AWS and Databricks-based pipelines are shown on the screen. For an existing pipeline where clusters are configured, you can click on this info button to look at the cluster details like name of the cluster, cluster type, core nodes, etc. For any new pipelines that you create, you'll have to start by configuring the job in order to submit it on the cloud. Depending on your choice of cloud provider, you will have to configure relevant parameters. For example, when submitting a job to Databricks, you can choose the type of cluster. It could be either a job cluster or an interactive cluster. When you configure a job or a pipeline on a job cluster, it will automatically shut down when your pipeline finishes execution. You don't have to worry about coming back to this console and manually shutting it down. You can also choose the runtime, machine types, and initialization scripts before launching the job. You can also define scheduling rules over here. Similarly, you can also configure the job to run on an AWS cluster. Here, we choose EMR-specific configuration, like, again, the job cluster or a long-running cluster, details of the master node, core node. You can also define auto-scaling rules on this interface. This may be both for scaling out and scaling in. If you are anticipating increasing loads, rules could be defined of how you can add additional nodes and how they can be released with decreasing loads. All of these features are designed to make sure you get full value for your money. After you have implemented the use case, submitted it on the cloud, the next part is managing them. The cluster list view provides a consolidated view for all the clusters you have used so far. This is a single page where your clusters for various cloud providers are listed. For example, in EMR, we can see how your long-running and job clusters can be seen. You can also see how your clusters are mapping to your pipelines. You can then either clone an entire cluster from this interface itself, or you can also launch a new cluster on the cloud itself from the same console. In case you have to submit a job on an existing AWS cluster, which is not listed over here, you can always fetch and get a specific cluster that exists on AWS. It will be then listed over here once you fetch the record, and it will also be available while you configure your pipeline jobs.
Thank you, Saurabh, for demonstrating the cluster management view of StreamAnalytix. As we saw on these screens here, StreamAnalytix helps us to manage all the cluster-related configurations, including the ability to create clusters, scaling out a particular cluster based on certain rules, policies, or depending on the amount of data that we would be processing for a particular workload. The whole idea and intent is that if a user is logged inside of StreamAnalytix, he never has to leave this interface for any of the operations and cluster management activities. It's a very comprehensive way of doing entire cluster management for all your providers, not just one, including the ability to see the logs, changing configuration, and also debugging your workloads on the cluster.
Thanks, Puneet. Now let's look at another aspect. We already discussed earlier that we also need a mechanism to orchestrate multiple pipelines. In a lot of cases, we have provided a dedicated interface where you can achieve all of this. The control nodes have operators to specify a logical start or end. All the pipelines you have created so far into the system are available over here so that you can easily orchestrate using this UI. You can drag and drop entire pipelines over here and decide the sequence as well as conditions that would govern the execution. Like if you want a pipeline to execute only if the previous pipelines have executed successfully, you would choose all success conditions. Similarly, you can define other cases of execution as well. We often need to take actions on successful and failure cases of pipelines as well. You can define them from the actions interface. In this example, if both the pipelines execute successfully, an email will be sent out to configured email addresses. Another aspect that often ETL developers struggle with is how to make robust ETL pipelines that can be deployed on production. We need a mechanism to test our pipelines, keeping a lot of scenarios in mind. In StreamAnalytix, you can also create test cases. In fact, you can create an entire test suite for various validation scenarios. On the run history, you can see historically how your pipeline's health has been based on the status of your test cases. That's how you can make sure that all your pipelines are robust enough before they can be promoted to production.
Thanks, Saurabh. And this is a feature that I would really like to emphasize and bring attention to, because as part of our customer implementation, this is something that we have seen often being used by customers. Most importantly, the question that developers ask is, hey, how do I do versioning? How do I make sure that when I create my ETL jobs and I keep changing the logic inside of it, Can you version it? Can you go back to a previous version? Once I'm done with my particular logic, is there an ability where I can also migrate or promote it to a higher environment for testing and therefrom all the way up to production? So this entire integration of test cases, test suite execution, and Git and CI/CD, all the three together come together in order to make this possible. So imagine a scenario where you are a developer or a user of the system. You come in on day one, you create your ETL job. Once you're satisfied, you create a version of it. The moment you create a version, the entire ETL job gets committed inside of Git, and your CI environment, which could be Jenkins or Circle CI, any of your continuous integration environment, it would extract that particular version from the Git, execute these test cases for you, and also automatically promote the pipeline or the workload to a higher environment if the policies governing that particular ask so. So all the way from creating your logic, versioning it, committing the changes into Git, automated test case execution and promotion comes alive with this whole integration of Git, Jenkins, and StreamAnalytix.
Thank you for summarizing that, Puneet. Let's take a look at another important aspect that most of us struggle with. Often when you move your data from a source to destination, you would always want to make sure that the data has properly moved in its entirety. But in a lot of cases, the data is transformed and it goes through a lot of changes. Therefore, running a count operation is not sufficient, as it may not give you a complete picture. In StreamAnalytix, we let you register your source and target destinations, and we call them data sets. Once you have a data set, all you have to do is run profiling on your data set. You will get a list of statistical functions which will give you a holistic picture. For example, you will get values like Q1, Q3, average, minimum, maximum, and a lot of other values as well. If I were moving, let's say, for example, if I were moving the sales data from source to destination, no matter how I transform my data, I'd expect my minimum, maximum, and average sales figure to be constant once the data is moved. So something like this could be really helpful. So you see how easy it becomes to manage your entire ETL pipelines end to end, take your use cases to production using a cloud-based ETL platform like StreamAnalytix. Now let me quickly summarize and show you some of the key highlights of StreamAnalytix. It is a scalable and extensible platform and lets you read data from almost any source, gives you a complete view of data before, during, and after the entire process of transformation happens. It is also a unified platform capable of handling both real-time and batch use cases, and thus providing a complete 360 view of your data. It comes bundled with support for a lot of open source technologies. It utilizes Spark as the distributed processing infrastructure under the hood. Along with various general purpose transformations, or what we call as operators, you can now also use machine learning algorithms to enrich your data. It not just allows you to build your application in form of pipelines visually, but also lets you manage the entire life cycle of your application. From iterative development, you can write test cases. There is provision for continuous integration and delivery, and eventually promoting stable jobs to production. Finally, we provide you an enterprise-grade application that is reliable, robust, and highly available to handle any kinds of workloads for your business needs. That's all I wanted to cover, and at this point, I would like to invite Larry to take us through the various options for trying out StreamAnalytix. Larry, over to you.
Puneet and Saurabh, thank you very much for a comprehensive description of how we can address implementing these workflows and pipelines on the cloud. Very, very interesting, and Saurabh, thank you for your demonstration. At this point, many of you may be asking, this looks very interesting, but where can I find additional information on this topic? And we've provided several different ways for you to do that. First of all, there are 3 different options to do a free cloud trial on the AWS Marketplace. Secondly, if you go to the website for StreamAnalytix, which is www.streamanalytix.com, you'll see this screen, and you have the ability, if you prefer to do a desktop trial, to download what we refer to as StreamAnalytix Lite. StreamAnalytix Lite is a full-function version of StreamAnalytix available to you on your desktop, and gives you the ability to execute all of the functions which you saw during the demonstration today, all of the different operators, and also to do that as a trial version. It is limited to a single node implementation, but that's another way that you can get additional hands-on with StreamAnalytix. In addition, you'll see a poll here in a minute, a second poll question, and the poll question says, would you be interested in a deep dive of the product as shown in the webinar? And if you answer yes there, we'll be sure to follow up with you and schedule a deep dive specifically for your team. What you are seeing now on the screen is the results of the first poll question that we asked. What are the challenges that you face in running ETL pipelines on the cloud? And we did give you the option of choosing multiple different of these. You see the number 1 has to do with managing the data movement back and forth to and from the cloud. Secondly, lack of the right skills, followed closely by lack of cloud native and manual development or lack of tools. But far and away the biggest one was the issue of managing data movement bidirectionally to and from the cloud platform. What we would like to do now is show you that second poll question, and there is still time for you to enter questions which you may have, and in a minute here we'll begin to answer those questions. The second poll question, as you see it here, says, would you be interested in a deep dive of the product? As I mentioned, we'll get back to you if you answer yes to that. But it's also very important that we do get the feedback on your user experience today, and we do that with the second poll question here. How do you rate your webinar experience? 5 being the highest from 1 to 5. You also have the option there, as you see in item 3, to give us comments or feedback on your user experience, how we can improve our delivery of these. We do a lot of webinars and very often get some very helpful suggestions through that. That being the case, what we'd like to do is move now to the Q&A portion of our meeting. We have, excuse me, we have a number of questions that have come in. The first one, actually, I just answered. It was, how can I evaluate the product further? You'll also have on another screen, which we'll show you in a minute, a way to get to us through inquiry@impetus.com. or inquiry@streamanalytix.com. Either of those will also give you a way to reach us with any other specific questions that you may have. The next question is for you, Saurabh, and it says, what version of Spark do you support? And if you could answer that one, please.
Sure. Our current version on cloud is 2.3.1, but as soon as Spark releases a new version, we get onto it, and we take some time, but eventually we get there. So the current version is 2.3.1, but if you are looking for any specific version, we could support that as well.
Okay, great. The next 2 questions are related, and Saurabh, you may want to pick those off also. Puneet, you're certainly welcome to jump in as well. It says, is this also available on Azure, and do you support reading from Azure file storage?
Sure. Absolutely. The product is available for Azure today. If anybody wants to deploy StreamAnalytix on Azure, please reach out to us, and we would be more than happy to set up a trial license for you. On the Azure file storage connector, yes, we have connectors to read from Azure file storage. Not just that, but even Azure blob storage is another connector that we can read and write to. There's another question that has come in. Can I run my own logic inside the platform? Yes, absolutely. StreamAnalytix has the capability to let the users write their own logic. So if you have a pre-written ETL logic that you would want to simply embed inside of StreamAnalytix, we completely support that. Right now, we support any logic that could have been written in Java, Python, or Scala. All the three languages are supported, so you can write your own logic in any of these. Next question is, do you support change data capture scenarios? Yes, we do CDC applications a lot. We see this as a very common requirement across all the different enterprise customers we work with. We do provide CDC capabilities for databases like MySQL, SQL Server, Oracle, Postgres, and so on. If you have a specific need for any of the other databases which I may have not mentioned, please feel free to reach out to us, and we will be more than happy to engage. What about Databricks on Azure? We do support Databricks on Azure. We are fully compatible with Databricks no matter where it is hosted. If it's hosted on Azure or AWS, we are fully compatible. We leverage the Databricks provided Spark. And like you may have seen during the demo, we do also let you create and manage the Databricks hosted Spark clusters through StreamAnalytix visually as well.
Excellent. Thank you, Puneet. I'm looking here at the questions. I think we've answered most of those that have come in. And I want to thank our audience again today and let you know that we invite additional follow-up and dialogue with you. And as I said, there's a number of different ways to reach out to us to do that. One of them you see here on this screen, www.streamanalytix.com for that free desktop download, and also inquiry at StreamAnalytix.com for more information on the product or to ask about a proof of concept, which we obviously do many of. Thank you very much. That concludes our webinar today, and enjoy the rest of your afternoon or evening, and have a great day. Thank you.